Now that we've taken a look at adding and subtracting, let's take a look at products and quotients of functions. So when we want to multiply functions or divide functions, we can write it two ways. So for multiplying, you can just put the functions next to each other, just like if I said 3 times x, I could write that as 3x. So same thing here, this just means multiplication. However, the second way you have to be a bit more cautious of, so it's going to be f times g. Now, that looks very similar as our other way of writing addition, like when I said f plus g. The one thing you have to be careful of, though, is this a solid dot? Okay, so that makes a big difference. You'll find out pretty quick that we have solid dots, and then we have the open dot, and they're going to mean very, very different things. Now, for a quotient of a function, we can write it two ways as well. We can write the full function notation over each other, or f over g of x. So our first example then, so given f of x is equal to x plus 2 all squared minus 5, and g of x is equal to 3x minus 4, determine h of x is equal to f times g of x. State the domain and range of h of x. Alright, so h of x is equal to, so we're going to multiply these two functions. So we're going to have h, or x plus 2 squared minus 5, and then multiply that by 3x minus 4. Now, before I go and maybe try to FOIL this, I'm going to see if I can do some more simplification in here. So that's a perfect square, so it's going to become x squared plus 4x plus 4 minus 5, still all times 3x minus 4. And we can combine some like terms here, so I get x squared plus 4x minus 1. And then 3x minus 4. Now we're going to have to distribute and expand this. So it's going to become 3x cubed, and then x squared times negative 4 is negative 4x squared. And then we get to 12x squared, and then minus 16x, and then minus 3x, and negative 1 times negative 4 is positive 4. So we should combine all of our like terms. So we got 3x cubed, and then for squared, it's negative 4x squared plus 12x squared. So we get 8x squared. And then negative 16 minus 3 is negative 19x plus 4. So this is our h of x then. Now we do have to do the domain and range. Now this is a cubic function. There's no division happening anywhere. So I know my domain is going to be from negative infinity all the way to infinity. And actually, for that very same reason, because it's cubic, I know that one end up will be going up and the other will be end up going down. Now in this case, it looks like it's positive, so maybe it looks more like that. So it is also going to go from negative infinity to infinity. If you're not able to see that though, you can graph it, or if this was an even function, you might have to see what the lowest point is on a graph. Okay, another nearly identical question. So given f of x is equal to x squared and g of x is equal to the square root of 4x minus 5, determine h of x, which is equal to f of x times g of x. State the domain and range of h of x. Alright, so we're going to find out h of x. We're going to multiply these. So we've got x squared times the square root of 4x minus 5. And because this is a square root, there's nothing else I can do to simplify this. So I'm done as far as turning my new equation. Domain's a little bit trickier though. So our other one was nice because it was cubic. This one we can't look at it this way. We have to look at the separate domains. So for x squared, that domain is going to be real numbers. So we can go from negative infinity to infinity. Now for our g of x, 4x minus 5 must be greater than or equal to 0 because we can't square root a negative. So then we're going to add 5 to both sides and then divide both sides by 4. So therefore x must be greater than or equal to 5 over 4. Which is more restrictive? Any number or x is greater than 5 over 4? Well, obviously x is greater than 5 over 4. So our domain for h of x then is actually going to be, it does include this 5 over 4. So 5 over 4 all the way to positive infinity. To find out what our range would be, you're going to have to graph this. And so when I go and look on a graph, I find that we go from 0 to infinity.